The next paper is by Jonas Metzger, The Carbon Contract Curve. Please go ahead.
Hi, thank you for letting me talk a bit about my ideas today. We're going to estimate the carbon contract curve, and if you Google those three words, you'll get 0 results. But we know the contract curve from microtheory. It's the set of all efficient allocations that would make all parties better off relative to the status quo. And our goal today is to apply that idea to the macroeconomy and estimate it for the topic of international agreements on carbon emissions. And why is that interesting? Well, it ultimately defines the set of contracts that we could ever hope to consider. I mean, if a contract is not an actual improvement upon the status quo for every single participating country, it's dead on arrival. And interestingly, a global national carbon tax where the revenues stay within the countries would not be a Pareto improvement for all countries. So there have to be transfers. And the question is, like, how much would every country be willing to pay for the global transition? We're going to be a very reduced form. Why? Because every country has an incentive to downplay their own willingness to pay to avoid climate change. And so we want to let the data speak as much as possible. We will ignore commitment issues at the international level. Please ask about that. It's a very interesting topic and crucially important, of course. In practice, there is no such thing as a country that can commit to do something, and if it changes its mind in the future, it will always have the option to renegotiate. And so people have been tackling that, and we won't have time for that in the talk, but there are ways to get to a second best. We can maybe improve that second best with modern technology. But today the question is, like, what is the first best? How much are we actually willing to pay? What's at stake? And what's the distribution of that? We're going to make it easy for us. We're going to assume we all have similar expectations for what will happen if we don't manage to reach an agreement. We're going to somewhat conservatively assume that a certain scenario called RCP7 from the IPCC is going to happen. It would involve a warming of 4.2 degrees by the end of the century. It will involve a reduction of the emissions growth rate in the future. That's the green line, but it will keep rising for a while. The main alternative to that we'll consider is if we started reducing our emissions today, ultimately ending at net zero very close to the end of the century, which would lead to a reduction of just below 2 degrees Celsius by the end of the century. We're going to assume that the whole thing costs $26 trillion. That's a recent study by colleagues at Stanford in the Environmental Engineering Department who calculate the price tag for a full transition of our electric grid to renewables, including all the storage costs that we will have. So now we can focus on the cost, the willingness to pay to avoid global warming, the cost of global warming. We're going to assume that weather is exogenous. Climate and GDP are probably confounded, but since we'll detrend everything, we'll just look at random weather variations. We'll look at if a hot year in the US is a good year for the US in terms of GDP, and that for all countries. Where we'll be different to previous literature is we'll allow for spillovers. So a hot year in Africa might also affect US GDP. And we're the first to do so, but cross-validation approach would overwhelmingly favor that approach, that specification. In fact, that doubles the cost of climate change. And so to back out and summing all these spillovers together, we can get an idea of the cost of marginal warming historically, of a marginally hot year for every country. If the whole Earth warmed, how does that affect the US versus China versus Japan? And they're all on this line if we order them by the average temperature on the x-axis. And we would see that warm countries tend to have the highest marginal cost of further warming. Cool countries tend to be indifferent or actually benefit a little bit if it gets warmer. The blue line is the average. The yellow line is what would happen if we ignored spillovers, so there's a huge difference. And the key assumption that we make is that we can extrapolate. So as a country gets warmer, it will move down that line. Now that relationship is not as strong or non-existent if you plot something like average income on the x-axis. So average temperature seems to be the biggest predictor. If you're concerned that we're underestimating the ability to adapt to climate change, I would argue it's the opposite. And if you repeat the analysis in the past and more recently, and you look at as countries got warmer, how did the marginal cost increase? You'll see that almost every country had a much more drastic cost increase than we would have predicted, basically because climate change is outrunning our ability to adapt. If we combine that with some projections for future GDP, we would see that in the future, India will have the largest benefit if we avoid climate change. Latin America will be hit hard as well. Europe down there is relatively speaking minor. But what matters today, if we're talking about a contract, is the ability of a country in the present to manifest those potential benefits from avoiding climate change in the future today. And so what's crucially important, and the way countries do that, is through bonds. A government, even if you're a dictator who doesn't care about future generations, you just want to have wealth today, if you manage to start a contract that avoids climate change, you can front load those benefits in the future through a bond that your future generations can credibly and would happily repay with the avoided cost of climate change. And so taking that into account and discounting, computing net present value using those 10-year bond rates that we currently observe, we end up with a very different picture. China, the US, and Europe have the overwhelming biggest willingness to pay to avoid climate change. And so it's somewhat a positive result, because that means the countries who could actually feasibly get that money together are willing to do so in principle, if they can trust each other or if there's some other mechanism in place. India is still playing a role, but a much smaller one. And Africa barely plays any role because it can't afford to internalize these costs today. So the space of all contracts, in my last slide, basically you can cut it up any way you want, and you can cut up all the willingness to pays at the bottom and decide whether a country is going to pay for the climate change or it's going to enjoy some surplus. You could do that proportionally, and so that everyone gets something out of it. If you want to take into account uncertainty, that's probably the best approach to take. Whatever you propose, it's most likely to be actually a Pareto improvement if some numbers are wrong, if you split it up proportionally. But it's a positive result. The countries who can actually afford to cause the change, to invest in this front-loaded transition to renewable, they are willing to do so in principle. Thank you for your attention.
I'm curious.
Yes.
Is Brazil an interesting country in your?
Yes, Brazil will face very high damages. Everything is sensitive to the assumption about future growth. Brazil can potentially be a very large economy, and they will play a big role. Given the current interest rates, they are unable to internalize a lot of the future benefits that avoiding global warming would bring. But again, like, if we're maybe thinking about the rainforest, and so if avoiding climate change.
A student by the name of Stefan Palacio studied.
Yes, and that's a great question. So there will a lot of the solution side will affect every country, right? We might want to invest in the rainforest to avoid global warming. In that case, I think it's important to not. That's kind of one of the most important perspective of a contract curve. In order to make Brazil actually prefer that outcome where it doesn't harvest the rainforest, the natural resource that they have and could use, the rest of the world will need to pay it and wants to pay much more than Brazil can harvest. And so you can make that part of the calculation. I think some reforestation is actually in the study. It's the cost side that I kind of abstracted away from and just summarized in that number. But that number could involve certain reforestation activities in the rainforest. Absolutely. Yes.
On the issue of commitments.
Great question, yeah.
It occurs to me that one way to make the agreement a self-enforcing agreement would be to adjust it dynamically over time. So you've calculated that, assuming you commit today for the future, everyone wants to join.
Yeah.
But you could do the same calculation. If the treaty could make the same calculation 5 years from now, 10 years from now, and as long as adjustments were made, it could always be self-enforcing.
Yes, that's right. There's a danger if it turns out that it would be cheapest to have some countries have an investment upfront, and they would presumably only be willing to do that if other countries also commit to investing. But maybe if other countries would have to commit only later, at a later stage, then there's no credible way for them to commit to doing so. That would make it difficult if there's an ability to renegotiate. But transitioning the whole world to a renewable electricity grid presumably requires continuous investments relatively decentralized across the globe. And in that sense, I think a renegotiating contract might be able to get us really close to the first best, even from the point of view of today. And so I'm very excited to dive into basically the cooperative game theory perspective of this that Nordhaus explored a little bit. Yeah.
Well, it might also be possible to write in to a treaty retaliatory measures against a country that pulls out. So, for example, you wouldn't trade with that country.
Yeah. Tariffs, like a continuous version of this. Nordhaus analyzed that in his Climate Club proposal. The way he analyzed it based on the numbers he was using, I mean, a lot has changed since then. A lot of our estimates have narrowed down. He got very far from the first best. The Climate Club ended up being a little bit small, not as big as you would hope when everyone is involved. But I think the perspective was a different one. It was about avoiding emissions. Here it is really about investing something, creating some new capital asset across the globe, which presumably has some better incentive structure. Great point. Thank you.
Thank you. Hopefully the discussion can continue outside of the room.